This is Dr. Ray Mao, research scientist from Nanyang Technological University. I'm glad to introduce our recent work, MetaPro 2.0, Computational Metaphor Processing on the Effectiveness of Anomalous Language Modeling. It's called MetaPro 2.0 because this is an extension of our previous works. We have developed an end-to-end metaphor processing system, MetaPro, which incorporates metaphor identification, metaphor interpretation, and concept mapping generation modules. However, there are two major limitations. First, due to the absence of the large annotated datasets for metaphor interpretation task, the former method achieved this goal by leveraging language models and knowledge base in an unsupervised manner. The metaphor interpretation performance can be potentially improved by learning from a large annotated dataset. Second, the previous metaphor identification and interpretation modules were developed based on general pre-trained language models. The performance of these two tasks can be potentially improved by tailoring the pre-training tasks that are more relevant to the aimed metaphor identification and interpretation fine-tuning tasks. Given the above limitations and hypotheses, we aim to develop a large metaphor interpretation dataset and a metaphor processing-oriented pre-trained language model in this work. Why metaphor interpretation is still important nowadays? Current AI techniques cannot understand metaphors well. For example, ChatGPT and a sentiment analysis API predict the sentiment polarity of a metaphorical expression, the comedian convulsed the children, as negative. ChatGPT explains that the word convulsed typically denotes a strong, uncontrollable movement or shaking, which is often associated with negative connotations. By the translation of Google, we found that current AI models likely misinterpret metaphors by their literal meanings rather than the real meanings. But if the metaphors can be identified and then paraphrased as their real meanings, for example, the comedian convulsed the children is paraphrased as the comedian amused the children, these errors on downstream tasks can be somewhat mitigated. Our previous studies showed that if an end-to-end metaphor interpretation system is used as a text pre-processing technique, the processed data can bring 4.7 gains in accuracy on average for 3 sentiment analysis classifiers. These improvements motivate us to enhance the utility of end-to-end metaphor interpretation systems by developing a large annotated dataset and a tailored pre-trained language model in this work. Our proposed dataset is called VMCP, VU Amsterdam Metaphor Corpus with Paraphrases. VU Amsterdam Metaphor Corpus is the largest metaphor identification dataset. We annotated the paraphrases of metaphors from the corpus at the lexical unit level. We approached the metaphor interpretation task as a paraphrasing task. We chose such a task setup because turning metaphors into their literal counterparts can most effectively support downstream applications as demonstrated in the previous slide. In total, we delivered metaphorical paraphrases for more than 10,000 sentences and almost 12,000 metaphorical lexical units in the VMCP dataset. The box on the right is an example from our VMCP dataset. The annotations include indices indicating the metaphorical words in a sentence. The positive list refers to paraphrases of metaphors. The negative list contains synonyms of the metaphors, while those synonyms are not the optimal paraphrases of the metaphors. The elements in the metaphor index list, positive list, and negative list are aligned by indices. We are seeking to find new pre-training tasks that are more related to our focused metaphor identification and interpretation tasks compared to conventional language modeling tasks like next word prediction, mask or missing word prediction. Our hypothesis is that if a pre-trained language model can learn metaphor-like linguistic patterns, the pre-training can yield better utilities for the fine-tuning stage. By the selectional preference violation theory from Yorick Wilkes, metaphors violate the selectional preference of their contexts. For example, given a metaphorical expression, she devoured his novels. The verb devoured is unlikely associated with the noun novels by statistics. Thus, it can be considered as the violation of its context preference. We can develop our pre-training corpus and tasks by simulating such selection or preference violation. For example, we can replace an original word in a sentence with another randomly selected but semantically related word to form an anomalous language. The replacement should be semantically related to the original word because a metaphor and its real meaning are also related. Thus, we replace an original word with a random synonym that is obtained from WordNet. For example, given a sentence, I'm driving a car, we can form another sentence with an anomalous word such as I'm forcing a car. Next, we propose the new pre-training tasks called anomalous language modeling or ALM. These tasks focus on identifying words that violate the selection or preference of their context and then retrieving the original word from a list of candidates. This candidate list is made up of synonyms of the anomalous word, including the original word itself. Recall that to create an anomalous word, we randomly selected a synonym of the original word. Since synonyms are mutual, the original word will also be among the synonyms of the anomalous word, ensuring it appears in the candidate list. We concatenated the candidate words after the original sentence and pre-trained a robotic model with these anomalous sentences. In the fine-tuning stage, the model needs to identify the metaphorical word, which also violates the selection or preference of its context. Additionally, the model needs to retrieve the paraphrase of the metaphor from a list of candidates, which also contains the synonyms of the original metaphor. Having a consistent task set up during both pre-training and fine-tuning stages can improve the effectiveness of the pre-trained language model for downstream tasks like metaphor identification and interpretation. In our experiment, we tested two frameworks for metaphor identification and interpretation tasks. One is a multitask learning framework which learns both metaphor identification and interpretation tasks simultaneously. The model consists of a pre-trained encoder based on the proposed anomalous language modeling paradigm, a linear layer that is used for classifying the metaphoricity of each word, and a contrastive learning task that retrieves the paraphrase of the metaphor from a list of candidates. The other framework is based on single task learning. There are two independent modules in this task setup. The metaphor identification model consists of the pre-trained ALM encoder and a linear layer. The metaphor interpretation model consists of the ALM encoder and learns the task via contrastive learning. We evaluated the two frameworks with the proposed VMCP dataset. We defined fine-tuned ALM as a MetaPro 2.0 model. The evaluation tasks include metaphor identification, gold metaphor identification label-based metaphor interpretation, and end-to-end metaphor interpretation. The end-to-end metaphor interpretation task is based on the predicted metaphoricity labels. For example, if the model identifies a word as a metaphor, it will be paraphrased. If not, it won't be changed. The end-to-end metaphor interpretation is closer to the real-world task setup because we do not know the metaphoricity of each word before conducting metaphor identification. First, we found that the ALM-based MetaPro model exceeds other parameter-size comparable pre-trained language models, such as BERT, Roberta, GPT-2, and T5 in single and multitask learning frameworks. It shows the effectiveness of our proposed pre-training method on the computational metaphor processing tasks. Second, we found that single-task learning performs better than multitask learning. This is likely because the multitask learning framework lacks advanced task-specific towers and softer parameter sharing methods that can learn more task-specific features for the metaphor identification and interpretation tasks. We will bridge this gap in the future work. Thank you.